In this video, I will explain you what is susceptibility. So in the previous video, we have learned about H. What is that? Magnetizing intensity, and M, magnetization. Yes, magnetization. Now, who creates the magnetization? H creates the magnetization, right? How? This was the experiment. We have a solenoid, and so near to the solenoid, we have kept a substance, a material. Now the solenoid, what we have provided? We have provided a magnetizing intensity of H as an input. Okay, now it has created a magnetic field of mu0 into H around it. Now with this, it has got magnetized, and the magnetization was M. So the magnetic field created inside the material is mu into mu0 into M. Okay, so this one is mu0 into H, and this one is mu0 into M. So I will put it together. Okay, so I have material, and covering this I have solenoid. So this one, it is magnetization, and this one magnetizing intensity. Now susceptibility has been defined in this way: M divided by H. How easily we can magnetize a substance? For example, I will explain it with numbers. Now, giving a value of H, 100, let's say a substance has developed a magnetization of 100. Okay, for example, it is 100 and 200, for example. Now, what is susceptibility? Susceptibility is, this one is H, this one is magnetization. So, 200 divided by 100. So, the value is 2. Now, for certain other material, when I have kept the same magnetizing intensity, I have got a magnetization of 400. Now, what is susceptibility? 400 divided by 100. The value is 4. Now, I can say that second substance is more susceptible. It can be easily magnetized. So, that is the meaning of susceptibility. It has been defined as a ratio between magnetization and magnetizing intensity. So from here I can simply get one more relation: M is equal to susceptibility into X. So susceptibility as represented will be represented in this way: X with a tail on it. Okay. So M is equal to susceptibility into X. Now when we are keeping a magnetic substance inside, and we have, and at the same time keeping a solenoid outside, the total magnetic field inside, we have learned in the previous lecture, that is B net is due to magnetizing field plus magnetized. That is due to magnetic intensity due to solenoid inside, that is B0, plus magnetic field intensity due to the material inside, that is Bm. What is B0? mu0 into H, plus what is magnetic field due to substance? mu0 into M. So what is total? mu0 into H plus M. This is the total magnetic field. Now I will write the equation here. B net is equal to mu0 into H plus M. Now for M, I am going to substitute this one. So mu0 into H plus M is susceptibility into H. So I can take H outside, mu0 into X plus H into 1 plus susceptibility is equal to B net. Now we have learned one more equation in the moving charges and magnetism. What is that? When we have a solenoid, and inside when we are keeping a material, what is the total magnetic field? That B net is equal to mu into Ni. Which we have learned in the previous chapter from moving charges and magnetism. Moving charges and magnetism. Go back and refer solenoid. Mu into Ni will be the total magnetic field inside the solenoid, where mu is equal to mu0 into mu r Ni. So mu0 is nothing but permeability of free space, and when you are keeping a material inside, we are keeping a material having a relative permeability of mu r. So the total permeability will be mu, and the value is mu0 into mu r into Ni. So I am going to, so it's the same case here, right, in both the cases. So I am going to substitute d net as mu0 into mu r into Ni. This is equal to mu0 into x into 1 plus susceptibility. Now Ni is h, we have learned in the previous video. Mu r Ni is equal to mu0 into x 1 plus susceptibility. So x will cancel, mu0 will cancel, and mu r is equal to 1 plus. This is very important, very, very important. There is higher chance for you to have a question about susceptibility in your coming board examination. So relative permeability is equal to 1 plus susceptibility. Now with this, we are going to get more equations. Okay, so I am going to rub this. Mu r is equal to 1 plus susceptibility. Now, what is the value of mu r? Mu r, we know mu is equal to mu0 into mu r. So mu r is equal to mu divided by mu0 from this equation. Mu is equal to mu0 into mu r is equal to mu by mu0. So mu by mu0 is mu r equal to 1 plus susceptibility. Okay, so we got the equation mu by mu0 is equal to 1 plus susceptibility. This is very, very easy. Now, from here, susceptibility is equal to, keep susceptibility here and take 1 to the other side. That is that mu by mu0 minus. Very, very, very important relation. Okay. Now, with this relation, we are going to learn 3 important concepts. One thing is, when mu is less than mu0, so now permeability of a substance, if it is less than permeability of free space, then the total value will be less than 1. So if the total value is less than 1, a small value minus 1 is equal to a negative value, which means x susceptibility is equal to negative. I will explain you what is negative susceptibility means. In the next case, when mu is more than mu0, susceptibility is equal to positive. That is very clear. So this greater than this, the total value is positive. Positive minus 1 will be positive value. Now certain material, its mu will be less than mu0. For that, susceptibility is negative. For certain other material, when its permeability is more than permeability of free space, its susceptibility is positive. Now what will happen when susceptibility is a negative quantity? So when susceptibility is negative quantity, let's say we have a solenoid here. Now with this solenoid, a substance will produce net magnetic moment, but the direction will be opposite to the magnetizing intensity. So this is magnetizing intensity, H is given in this way, but this will produce a net magnetic moment that is opposite to this one. Okay, for example, if the total magnetic field intensity created by magnetizing field, if it is 100, now negative substances with negative susceptibility will produce, let's say, a magnetization of 20. So I am talking about field. So 100 is the input, 20 is produced here, but this is in the opposite direction. So what will be the net magnetic field? If you are keeping it inside, 100 minus 20, that will be 80. So it was 100 before, now it is 80. Now if susceptibility is positive, this will produce, this number will be positive. Now the net magnetic moment created by the material will be in the same direction as that of the magnetizing intensity. So this will be plus 20. If this is 100, 100 plus 20, it will be 120 in total. So this magnetization will occur opposite direction. Here magnetization will occur in the same direction. Clear? So for one example for this is copper, another example for this. So one example for positive susceptibility is iron. So copper will produce a magnetization but opposite direction. So net will reduce. Now here it will produce in the same direction. So net inside this